Hey everybody, in this video we're going to talk about several different statistics. The one we're going to focus in on most though is the standard deviation. So our objective is to find range and standard deviation, but again we're really going to focus more on standard deviation. The range is the largest number in a data set minus the smallest number. So in this data set the largest number is 9, so the range is 9 minus the smallest number in the data set, which is 4, so the range is 5. Standard deviation is the measure of the spread of data. So if data is spread out a lot, then we're going to have a larger standard deviation. If the data is not very spread out, but it's closer together, then we're going to have a smaller standard deviation. To find the standard deviation, there is a formula for it, but what we're going to do is use a graphing calculator to find multiple statistics, including the standard deviation. So to do this, we are going to use the Stat button, and under Edit, we're going to choose option 1, Edit, and we're going to edit List 1. Now, I've already got some things here in List 1, so I'm just going to go up to highlight List 1, hit Clear, and go back down, and my list is cleared. And now I'm going to type in this list. So 5 and then enter, and then 4 and then enter again. Alright, now I have typed in all the numbers and I'm on number 17, which means I've typed in 16 numbers. And let me just verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've got the right number of numbers input. So now I've got my list made. I'm going to go back to Stat and over to Calculate, and I'm going to calculate some single variable statistics. So that's option 1. And I was in list 1, and I'll go back and verify that. So if I go back to Stat and Edit, this was in list 1. If I happen to be in list 2, I can fix that in the next screen. So Stat, and then over to Calculate, Single Variable Statistics. And what I would do here is change the list. If I was in list 2 or 3, then I would use the second button, and if I was in list 2, I would use second and then option 2 here for list 2. If I was in list 3, then it would be second 3. So I can choose what list I want to calculate my stats for. And then I'll hit enter, enter, and enter again. And here are my statistics. So let's talk about what all of these statistics mean. So the first one, that's the mean. So x with a bar over it, that's the mean, it's 6.125. The second one, sigma x, so that sigma in math means summation. So that means that the sum of all of these numbers here in the list is 98. And if I look down here, n is 16. That means there's 16 numbers, so what that really means is if I take that 98 and divide by 16, that's how I can get the mean of 6.125. The next two that we are going to look at, S, X, and then this is a lowercase sigma, sigma X. Those are two different standard deviations. So there's S, X, and that is the sample standard deviation. And sigma x is the population standard deviation. Both of them are pretty small and they're close together. So we've got a sample standard deviation of 1.31 and a population standard deviation of 1.27. They're both pretty small, which makes sense because the data here, it's not very spread out. One of these is more appropriate for this set of data, and the one that's appropriate for this one is the population standard deviation. And here's why. A sample standard deviation is what you use if you're taking a random sample of a larger population. So if this was a survey randomly taken, and we're going to try to apply this mean to a larger population, and all we have here is a sample of the population, then we would use the sample standard deviation. The numbers that we're using here are not intended to be a sample of a larger population, so this set of numbers is its own population. So in other words, they don't represent any more numbers than just what's in this list, so the population standard deviation is what's appropriate here. All right, we've got an arrow here, so let's see what's left. So we'll scroll down, and we see the minimum x is 4. That's the smallest number. The maximum x, the maximum number, is 9. So we could use that to find the range. 9 minus 4 gives us the range. So the smallest number is 4. The largest number is 9. The median is 6. And then we have Q1 and Q3. Those are quartiles. So we have Q1 is 5. Then the median is 6. And Q3 is 7. With a minimum of 4, that means that the first quartile is from 4 to 5. The second quartile is from 5 to 6. The third quartile is from 6 to 7. And then with a maximum of 9, that means the fourth quartile is from 7 to 9. So quartiles take our list of numbers and split them up into the lowest quarter, the second lowest quarter, then the second highest quarter, and then the highest quarter. What that's sometimes used for is for finding the interquartile range. So the interquartile range, and I'll just list that here, is the IQR. The interquartile range is found by doing Q3 minus Q1. Now in this case, that would be 7 minus 5, which is 2. But this is also a set of numbers where I wouldn't really bother with an interquartile range, because what an interquartile range does is it eliminates outliers. So if you have an extremely high number at the end, so let's say with this set of numbers, our last number is 300. Well, that's a pretty big outlier for this set of numbers. So the interquartile range would eliminate that outlier and give us a more reliable range for this data set. So next, we are going to look at some river lengths. So these are some lengths of some of the longest rivers in the world. 4.16 for the Nile, that's 4.16 thousand, so 4,160 miles. So what we're looking for here is the standard deviation. So we're going to go back to Stat and edit our list. And I'll go up to L1 and clear it and start putting in the number of miles, 4.16 thousand, and then 4.08 thousand. Okay, so my list is complete. So I'm going to go back to Stat and over to Calculate, Single Variable Statistics. And I've got two different standard deviations. So I've got the sample standard deviation and the population standard deviation. So to decide which of those we're going to use, we have to decide if this set of rivers is intended to give me statistics that I would then apply to more rivers. So would I say that this average represents an average of rivers around the world, or is it only going to be applied to these 5 rivers? And I would say that I cannot apply any statistics from these numbers to other rivers unless I had all the rivers in the world and I took a random sample of those rivers. But that's not what's happening here, so the population standard deviation makes sense here. The population standard deviation for this population of rivers is 1.05. Now that does not look like a very large number, but remember these are in thousands, so that really means 1,050 miles is the population standard deviation, and that is actually kind of a large number. And it makes sense that I would have a large standard deviation because my numbers are 4,160 all the way down to 1,780. So that is a pretty large spread, so having a pretty large standard deviation makes sense. Now, what does a standard deviation actually mean? So here is what's called a normal curve. It is a bell-shaped curve, and in this case, it's called normal or symmetric because of the way it peaks in the middle, and it's about the same on both sides. And in the middle of this is the mean, and if it's exactly normal, then the median and the mode are all right at that same spot. Now, if it's not exactly a normal distribution, but it's close, then the mean, median, and mode would all be pretty close to that same spot. So a standard deviation means, in this case, that anything within one standard deviation of the mean is within 1,050 miles of the mean. So I'm going to make a mark here and then one over here and say that each of these is one standard deviation above and below the mean. So anything that falls within this area is within one standard deviation of the mean. In a normal or symmetric distribution, about 68% of the data will fall within one standard deviation of the mean. If we move out to a second standard deviation, so another 1,050 miles above or below the mean, so we'll call this area over here a second standard deviation. In a normal distribution, about 95% of the data will fall within this range right here, within 2 standard deviations of the mean. And then when I move out to a third standard deviation, about 99.7% of the data will fall within 3 standard deviations of the mean. And that leaves 0.3%, which means out here is only 0.15%, and out here is the other 0.15%. Okay, so those could possibly be considered outliers. Okay, so that's what standard deviation means. We're going to do one more problem here where we find a mean and a standard deviation. So the table shows populations in millions of 11 eastern states as of the 2000 census. Find the mean and standard deviation of the data to the nearest tenth. So that means we're going to have to go back to stat and edit and clear out our list and put in the 11 states in this list. So we've got 19.0, 12.3, and so on. Okay, so my list is done. So now I'll go back to stat and calculate single variable statistics. And I get a mean of 5.4. So it said round to the nearest tenth, so that's 5.4. So the mean among these states is 5.4 million. And the standard deviation, so I have to choose between either the sample standard deviation or the population standard deviation. So I have to decide if these states are to be representative of a broader population, which means more states around the United States, or if they only represent what's listed here. So these are 11 eastern states. This is not a random sampling of states that's meant to project statistics on the rest of the states. It's just 11 states standing by themselves. So this will be a population standard deviation, and that is 5.6. So 5.6 million which is a pretty large spread, which makes sense considering we've gone from 0.6 million, so about 600,000, up to 19 million. That's a very large spread, so we should expect to have a very large standard deviation. So that means that about 68% of these states will fall within 5.6 million of this mean of 5.4 million. And then we should have about 95% of the states listed here falling between two standard deviations. So 5.6 million times 2, so that would be 11.2 million of that mean. Now your percentages of what falls within how many standard deviations are going to vary, especially with a smaller sample. We only have 11 here in this sample. The larger the sample you get, the closer you're going to be to having your numbers fall correctly with these percentages within the number of standard deviations of the mean.